All right, 10 o'clock. We'll go ahead and get started here. So welcome everybody. My name is Bobby Henderson. I work in our hydronic and plumbing group here at Long. Today with me is Matt Thielken from Thermacor Process. And the title of today's presentation is Protecting Your Underground Piping Investment. So without further ado, I'm going to turn it over to Matt here, and he's going to talk with us. And stick around to the end. Sorry for the weekly prize drawing, and then we'll announce next week's presentation. So take it away, Matt.
All right, Bobby, I appreciate it. Thanks for having us on today. Certainly appreciate everybody's attendance here. And as Bobby mentioned, my name is Matt Thielken with Thermacor Process. We'll be speaking to you about a few ways that we can help protect your underground piping distribution networks. Looking at piping systems where when it comes to district heating and cooling market, our piping technology isn't exactly what you'd say on the sexy end of the spectrum when it comes to all the advances we've seen in pumps, chillers, boilers, heat exchangers, et cetera. So, in fact, most of our systems are designed to be buried and forgotten, which really is what can lead to problems if they're not installed correctly. So today we put together a few items that can be included in your projects, hopefully to eliminate the problems that we see that are encountered most often. So what we'll do here is I'll provide you a brief product description, specifically our two main staples for both high temperature and low temperature distribution. We'll touch on the primary failure mode of pre-insulated piping systems that we see most often. And then we'll address a few items that can go a long way to solving these issues, including our electrofusion pressure testable joint closures, ERM leak detection, and then finally our direct buried pre-insulated valves. So for those of you who are unfamiliar with Thermacor, we're one of the largest manufacturers of pre-insulated piping systems for the district heating and cooling markets in the United States. We've been providing these insulation systems since 1964 and continuing to invest in the technology to hopefully make our systems more efficient and more economical. So moving into our first product type, the first main line that we use is our Ferrotherm System. This is going to be for operating temperatures under 250 F. So it's going to cover most of your chill water and hot water applications. As you can see in the picture here, it's going to be comprised of a carbon steel carrier pipe, polyurethane foam, and a high density polyethylene jacketing. So this is a bonded foam system, which means the entire system moves underground as one unit. And we account for expansion of the system externally with bolster padding at expansion loops or other changes of direction. So the next main product type is our Duotherm 505 system. And this is for high temperature distribution over 250 F. So that's going to capture all your steam and condensate and your high temperature hot water distribution applications. It's comprised again of a carbon steel carrier pipe, but we'll use a wrapped insulation rated to 1200 F. Most of your systems you'll see commonly use mineral wool or aerogel insulation. And this is all within a carbon steel casing that's insulated again with polyurethane foam and a high density polyethylene jacketing. So it's what we call a Class A system. It's drainable, dryable, and testable. And the carrier pipe is centered and supported within that conduit, which allows the pipe to move internally independent of the outer casing and jacketing. So really the common theme between these, both the low temperature and the high temperature systems is going to be the application of the polyurethane foam and the Hdpe jacketing. So we utilize a spray foam, which allows us to apply that Hdpe jacketing directly onto the foam after visual inspection. So we can guarantee that there's no voids in your system. And both the foam and the jacketing are high dielectric strength materials. So that eliminates the need for any additional corrosion coatings or any cathodic protection systems at all. So along with 95% of the other pre-insulated piping manufacturers globally, we have standardized on the Hdpe high density polyethylene as our primary jacketing material. The jacket is homogeneous, so any breach in the system is readily visible and easily repaired prior to burial. It has an elongation value of 400 to 800%, which means the material is going to flex rather than break under sharp impact loads. And finally, of equal importance, it is a thermoplastic jacketing material that's fusible. And so there's no other jacket material in our market that thermally fuses to itself. And this characteristic allows us to manufacture a field weld repair kit that can be fused and pressure tested. So this leads us into the main failure mode of pre-insulated piping systems. The chart you see here is from information gathered in Germany. As you'll see along the bottom, the data is dated, but the theme remains consistent year in and year out and continues today. And that's that the number one failure mode of the pre-insulated distribution systems is from failed joint closures that are installed at the weld locations in the field. And so typically this is going to be due to improperly installed joint closures. So at the end of the day, water ingress from the outside in is the killer of these systems. It's not internal corrosion or carrier pipe leaks. So since 1997, Thermacor has been manufacturing our electrofusion pressure testable joint closures. And because we don't have an ASTM standard for pre-insulated piping systems here in the US, we've had our closures tested to the European EN 489 standards. And when compared to adhesive backed or other alternative industry standard closures, the electrofusion joint is significantly more robust. And when it's installed and pressure tested, the joint absolutely guarantees the water and tight integrity of the jacket. So as you can see in this picture a little bit closer, we're actually utilizing an Hdpe split sleeve. It's manufactured with the same 4710 resin that we utilize in our jacket. And that's the same material, the same resin that's used in Hdpe pressure pipe. So the concept here is quite similar to an electrofusion coupling that you'd see on an Hdpe water line, where we have a stainless steel wire embedded in a 4710 material. The wire is going to be extrusion welded along the circumferential and the longitudinal seams of that split sleeve here at my shop. You'll notice in this picture the leads that are coming out of the closure. And we're simply attaching a dedicated power source to these leads, which heats the material and thermally fuses the closure to the surrounding jacket. So once that joint cooks for about 20 minutes and is allowed to cool, we can put a positive pressure test on it to approximately 5 pounds in the joint. And of course, if no air escapes the joint, then we can clearly observe that no water can penetrate that joint either. At the end, we'll provide a polyethylene friction weld plug that seals the test hole. And finally, as an additional belt and suspenders, we'll use a heat shrinkable sleeve over the entire configuration. But one thing I think it's important to point out, you'll note that all of the work is being performed at the 12 o'clock position in the trench. So one of the biggest drawbacks that we see to the shrinkable closures is in order to properly install them, the contractor actually has to get down under the 6 o'clock position with their bellowed flame to shrink that closure. And we often see that as an area where not enough attention is going to be given. So in this next picture, we're demonstrating a cross section of the fusion weld. In performing the tensile strength test on this joint, the material actually fails on the jacket as opposed to the weld, as the weld becomes stronger than the material surrounding it. So you can visually see that there's absolutely zero pathway for water ingress into a system that's sealed with this closure. And so really it's the best way to guarantee a proper installation. We're always going to require a log sheet to be completed with the pressure test information on each joint in order to issue that warranty, so that we can confirm that it's done correctly. But in the event that a joint is still improperly installed, or of course if there's damage to the piping system during a subsequent excavation, we can also include our electric resistance monitoring leak detection into the system in any application that utilizes that exterior polyurethane foam and Hdpe jacketing that we looked at before. So the Erm system works exclusively on Ohm's law, so we know that there's no false alarms. It minimizes the repair costs by detecting leaks before serious damage occurs. And at the end of the day, it's going to hold both the manufacturer and the contractor accountable for the work. Basically, it tells on you if you did something wrong. So the Erm system is simply a bare copper wire. It's embedded in the foam between the foam and the Hdpe jacket. And we're simply measuring resistance between the bare copper wire and the carbon steel pipe. So if resistance is infinite, we know the system is dry. And of course, if resistance is approaching zero, we know we've got moisture in the system and we have to take a look at it. In taking it a step further, we can also use that same leak detection wire to locate the leak. So the system goes into alarm, you know you have an issue, there's a fault in there somewhere. So we can utilize a TDR, or a time domain reflectometer, which sends a pulse of energy down the wire. And depending on how long it takes for that pulse of energy to get back to the instrument, we can locate a leak or fault to what we call quote unquote backhoe accuracy. Now, all of our systems also come with a field weld map, so we can further isolate where to dig by looking for that field weld location that's closest to the TDR readings. So we can generally tell you exactly what joint you're going to have an issue at. So really, in summary, including the fusion closures on your systems keeps the water out, and including the leak detection on the systems allows you to proactively monitor them. And so finally, for discussion today, we'll look at the long stem valves that are designed to be pre-insulated for direct burial. These are for bonded foam systems only, so they're really applicable to the hot water and chill water distribution systems. Regrettably, they're not yet rated for steam. But the idea here is that we're eliminating yet one more problem that faces a designer of a district heating and cooling system. And that problem is, how do we keep our valve vaults from flooding and increase the longevity of the mechanical equipment inside the vault? So we've come up with a solution, and the answer is to utilize the fully welded and insulated valves to eliminate your vaults altogether. So these valves are low profile, so they can be insulated and easily integrated into the system. And we'll actually insulate and jacket these valves all the way up to the stainless steel operating nut, so as to fully protect all of the components within the valve. I guess over the past 7 or 8 years, we've developed a relationship with Bexby out of Finland. For those unfamiliar, Bexby is one of the foremost valve manufacturers of district heating and cooling systems, or valves, in the European market. And all these valves are going to have stainless steel balls or discs, and they're going to be weld end, whether we're providing ball valves or butterfly valves. So we're not having to worry about flange connections underground. The ball valves are available up to 24-inch, and butterfly valves are used for anything larger than 24-inch. But all of these valves are going to be designed to be operated from grade with a T key. So you can see here where the cost of a butterfly valve versus a ball valve really starts to diverge at around the 12-inch or 300 millimeter mark. Most of our customers prefer ball valve when available, but on the larger sizes, it can be more economical to use a butterfly valve. So on these ball valves, you can see here the floating construction of the ball valve, which guarantees tightness of the valve when the pressure difference is high. And of course, over here on the right, you'll see the spring plate that guarantees the tightness of the valve when the pressure difference is low. These valves are going to be offered in both a reduced port, which is what we see most commonly in the district heating and cooling systems. That does cause some pressure loss, but generally it's acceptable for the district heating and cooling systems. Full bore valves are available, but unfortunately they do require more material, which makes them more expensive, and of course lengthens the lead time. So most of our customers we do see going with the reduced port valves. Again, I said that the majority of our hydronic systems are under 24-inch, so our customers prefer the ball valves, but we do also operate and offer the butterfly valves. They're designed also for heating and cooling, metal seated and maintenance free. Just like the ball valve, they offer total tightness in both flow directions with that metal to metal sealing system. And then the body is a rugged, fully welded carbon steel pipe. So whether it's a ball valve or a butterfly valve, we design the valves into the system at or around anchor locations, which eliminates any bending or shearing forces on the valve shafts. And because we're able to insulate and jacket these in the factory, we can ensure that they're watertight, which eliminates typical maintenance costs as well as added costs of premature replacement. So in recapping the presentation, the 3 easiest ways to increase longevity of investment are making sure the system's properly sealed and tested, being proactive so that you know if you have a leak, and of course you can repair it, locate it and repair it. And finally, taking advantage of the low-hanging fruit by eliminating vaults where possible, because these are several of the areas that we know to be problematic. So hopefully we provided some value to you and you found this productive, but whether you're utilizing the components today or want to look at them further, of course, Long Building Technologies and Thermacor are happy to provide any additional information. So please just let us know how we can help.
All right, thanks, Matt. You want to take us to the next slide here? All right, for today's giveaway, again, want to thank Matt for his presentation today, and thank you all for joining us. Really appreciate your attention. Please join us next week where we'll be talking about refrigerants in the HVAC world. What is the correct path to take on refrigerants in today's HVAC equipment? So thank you all once again, and have a great rest of your day. Take care.
Thanks.
Thank you.